All right, textbooks out, open to page 144. You did review numbers 2, 4, 5 through 10, as well as the 11 through 23 odd in the practice section. We'll take a look at that here in just a moment, but we're going to start by looking at the review 2, 4, and 5 through 10. 11 through 23, and then there it is, 2, 4, and 5 through 10. All right. Starting with number 2, we were given an absolute value equation, and of course the first key to solving the absolute value equation would be to isolate the absolute value. That's going to be true for inequalities as well, but once it's isolated, the key thing to remember, Maddie, is we're going to set whatever's inside the absolute value equal to both the positive and negative, whatever's on the other side. So that 3x minus 2 is equal to both 8 and negative 8. And so we'll solve each of these equations. Maddie, what were your 2 answers that you had? Good, 10/3 and negative 2 are the 2 answers. Did you get those, Brecken? Looking at number 4, we had 4x positive 2 absolute value is equal to 22. Again, 2 equations, one in which 4x plus 2 equals, the other in which 4x plus 2 equals negative 22. Your 2 answers for number 4. Good, 5 and negative 6, those answers. Number 5, just a basic inequality here. Distribute, get rid of the little x and all that kind of stuff. What was your answer, Maddie? Good, x is less than negative 5, or you might have had negative 5 is greater than x. Number 6, Brecken. Again, distribute, this time combine like terms, then get rid of the little x and all that jazz. What'd you get? Good, 5 is greater than or equal to x, or perhaps you had x is less than or equal to 5. Number 7, Maddie. This time, probably, we had to deal with a negative x. The question was whether you moved it or whether you just switched the inequality around as you divided out the negative. What did you get for your answer on number 7? Good, x is greater than or equal to 8, or perhaps you had 8 is less than or equal to x. And number 8, Brecken, same type of problem. What did you get?
X is greater than or equal to 6.
Close, Maddie. Should have been x is greater than or equal to negative 6. Let's go and take a look at this real quick. Brecken, I assume the first thing you did was you subtracted the 7 away, or did you multiply everything by the LCD? All right, so you multiplied everything by 3. Now, here's where we have to be careful. When these 3's cancel, what am I left with? Good, not x, but negative. X here, of course, you would have gotten, and here, 27. I assume then you subtracted the 21 over, or did you try to pull a double switch? Subtracted the 21 from both sides, and that should have given you not x, but negative x is less than or equal to 6. So then the last thing, you got to this point, correct? Checking your work. The last thing we're going to do is get rid of the negative, and to get rid of the negative, you just divide both sides by negative 1. When I do, that of course just leaves me with x. I flip the inequality to get, but 6 divided by negative 1 is negative 6, and that should have been the answer. Did you perhaps have that and just not see the negative?
I did all the work just like that. I just didn't write down the negative.
So right at the very end, just lost the negative. Okay, so just be careful with that. Do we need to see any of the others worked? 5, 6, or 7? 5, 6, or 7, need to see any of those worked. All right, number 9, the sum of 2 consecutive odd integers is greater than 36. How would I represent consecutive odd integers, Maddie? All right, and so when it says the sum of these integers, we would represent that. And it says that that sum is greater than 36, so of course I'll write. There we go. To solve, of course, we'll subtract the 4, we'll divide by 4. We'll end up getting x is greater than 8. But that doesn't tell me what my integers are. The integers are 2x plus 1. So 2 times 8 plus 1 would give us 17. And the next consecutive integer would be 19. So my consecutive integers must be greater than 17 and 19. They could be 19 and 21. They could be 21 and 23. They could be 57 and 59. As long as they are greater than 17 and 19, my consecutive odd integers would satisfy the inequality. Did we get greater than 17 and 19 for number 9? Question. You did 2x and 2x plus 2? All right. And that obviously would have thrown things off just a little bit. How about number 10? Go and take a look at this one. Bracken tractor trailer's maximum load, 32,000 pounds. That'd be 16 tons. It's already carrying a forklift that weighs 8,200 pounds. How many 250-pound pallets of sod can it legally carry in one trip? You ever seen one of these sod trucks driving down the road and little pieces of dirt hitting your windshield? Anyway, so how should we set up this inequality, Bracken, to represent what we've got going on here?
8,250
There we go, good. We've got the 8,200-pound forklift plus some unknown number of pallets, each one of which weighs 250 pounds. That all has to stay less than or equal to what is called the maximum load, 32,000. From here, we, of course, would have subtracted away the 8,200, and when you did so, you got... it should have been 23,800. So your inequality was perfect. Maybe the solving of it, well, not so much. Should have subtracted away 23,800, Maddie, is what you had as well. I'm going to go and knock off the zeros first, and then divide away the 25. I think that'll make my life just a bit easier. And 25, of course, can't go into 23. How many times would 25 go into 238? Anyone? Okay, strategy tip on 25s. Think quarters. How many quarters make $1? 4. How many quarters make $2? 8. How many would make $2.25? 9. $2.50 would be 10. We're between 250 and 225, right? So we would say this goes in 9 times, but that's 225, right? So it still gives me 13 cents left over if you wanted to think money. How many quarters would go into $1.30? 5 with a little bit left over, right? 5 point something. But this is x is less than or equal to. So I know I'm going to round down regardless of what the decimal comes out to. So we would say I have to stay less than or equal to, class, 95 pallets of sod. And there's our answer for number 10. Question, Bracken, on number 10. Maddie, did you get 95 for your answer? You did not. Did you get the correct inequality? All right, just division error perhaps. Okay, careful with that. Another way to look at this, class, is does 25 go into 23? No, but it's really close. Usually if it's really close, the next numbers, when you have to go to the next thing, you go with a 9, generally speaking. That's a strategy tip you should have learned in 4th grade. But anyway, I digress. Let's look back up the page. Page 144, you're supposed to graph or solve each compound inequality and graph the solutions. We had not been graphing, but I think I will, even if you did not. I'll go over the graphs here as we look at the homework. Number 11, we've got a -3 is less than -x is less than 2. And really, to get the x by itself, there's only one simple step, Maddie. I'm sorry? Divide away the negative, right? Divide everything by a -1. When I do so, of course, this gives me a, this gives me, and this gives me -2. But I have to remember, anytime I divide by a negative bracket, I've got to, so my less thans become, and on the surface, if this was all there was to it, this is pretty easy, but there is one last step. Because remember, on the number line, 3 is not down here and -2 here. This is exactly backwards. So we said we have to flip the whole inequality around. Maddie, what did it look like when you reversed the entire inequality? Right, is less than 3, because the point still needs to be aiming at the x and the mouth still needs to open at the 3. So that now, as I look at my number line here, I can put what on the -2, class? And on the 3, class? Circle. And we're going to shade everything in between on this compound inequality. This is called an open inequality, remember, because both dots are open circles. Number 13, negative 8 is less than negative x plus 3 is less than 2. And Brecken, 2 steps on this particular problem. Walk me through. Good. Subtract 3 from every part of the inequality. What do we get when we do that? All right, the next thing we need to do, and when I do, all the signs are going to change to positives, and both of these signs are going to change to greater than. But of course, 11 and 1 don't look like that on the number line. It's entirely reversed, so we reverse the whole thing around. Now, where does the mouth open for this symbol here? Right, it's got to be aiming at the x, so 1 is less than x. And x is now less than the 11. So again, on the number line, another open inequality looking something like that. Number 15, we had a negative 1 is less than 5 minus x is less than 8. They aren't big on mixed inequalities, I notice. Again, another open inequality. And Maddie, 2 steps. To get? And then flip it around. Is less than. Okay, a properly written inequality, in case you haven't figured out the pattern yet, is always less thans, because they have to get progressively bigger, right? So the negative 3 is the smallest, it's less than the x, but the x is smaller than the 6, so it's less than x, which is less than 6. So a proper inequality is all progressive less thans, unless, remember we looked at something yesterday where there were 2 outside ranges, but you can't write it as one continuous thing then. You have to write it as 2 separate inequalities there. And again, for this, circle on negative 3, circle on 6, zeros somewhere in the middle, and of course you shade everything in between. Number 17. Negative 9 is less than negative 2x plus 5. They're not big on the or equal to's. Is less than 8. Brecken, 2 steps.
Negative 14 is less than negative 2x is less than 3.
Then?
Divide everything by negative 2. 7 is greater than...
Could be divided by the negative.
X is greater than 3 over 2.
Well, negative 3 over 2, right? There's only one negative, so move it to the front. And then let's flip it around.
Negative 3 over 2 is less than x, which is less than 7.
There we go. And of course, now on the number line, this is where it gets fun, is when you get fractions, right? 7 is easy enough to graph. Where is negative 3 halves? What is negative 3 halves, class? Negative 1.5. So if here's negative 1, here's negative 2, you'd have to put the circle right in between negative 1 and negative 2. Of course, the other circle's on the 7, and we would shade in between. Does that make sense? Questions on that? Let's see, number 19. Really only one step on number 19. All we have to do, Maddie, is multiply everything by 3. What do we get? Nice and loud so the camera can pick it up. All right, we won't get you on the stage when you're older. Negative 15 is less than x is less than or equal to 21. I work on that projection. Anyway, 2 steps on number 21. First, Brecken, we need to good. What do we get when we multiply everything by the 5?
Negative 5 is less than or equal to f plus 1, which is less than or equal to 5.
And then finally, our last step would be to just to get
Negative 6 is less than or equal to x, which is less than or equal to 4.
Good, and for the first time we have a closed inequality where we're going to have a solid dot on the 4 and a solid dot on the -6 and shade everything in between. Again, on the previous problem, Maddie's problem, we would have had an open circle on the -15, way far away, a closed dot on the 21, and then shade everything in between on that mixed inequality. Number 23, Maddie, 3 steps to follow here. First, we need to get all right, then and then finally to get less than or equal to. We didn't divide by negative, so don't flip anything. There we go. And again, solid dot on the -5, solid dot on the 4, shade everything in between. Questions on those? Do we feel like we've got compound inequalities pretty well down? Turn over to page 148. Page 148 in the middle section. Page 148 in the middle section. So you see there's a practice, there's a review, and there's a review of solving inequalities. I want the review 4.7, numbers 2 through 10, the even. Page 148 there in that middle section, numbers 2 through 10, the even. You don't need to graph the inequalities for sake of time, so just solving them. Okay, Maddie? All right, for sake of time, let's go and take a look at 2 through 10 even here. Number 2, what did you get for your answer, Brecken?
-2 is less than x, which is less than
You forgot to add the 1 to everything.
5.
5. Yeah, -2 is less than x is less than 5. Number 4, Maddie. Good. -5/4 is less than x, which is less than 2. Number 6, Brecken.
3 is greater than x, which is greater than -2.
Look at your numbers. Does that look right? Picture your number line. Here's 3, here's -2. Also, do we ever use greater than symbols? No, the numbers progressively get larger. So it's not wrong, it's just not finished. All we have to do is flip it around to get.
2 is less than x, less than
There we go, and that's the proper way to leave our answer for number 6. Number 8, Maddie. -1 is less than x is less than 2. Number 10, rates at a car rental agency. $120 a week plus 15 cents a mile. Brooke rents the car for a week. How far can she drive if she doesn't want to spend more than $225 on this rental? Maybe it's one of those, her car's in the shop, need to get worked on, and she's not really planning to go anywhere, but she's not sure how far she can go because she wants to stay under budget or what have you. How would I set up this inequality, Brecken? Well, no more than, it doesn't necessarily mean less than or equal to. There we go. Because 225 wouldn't be more than 225, right? So less than or equal to. Is this what you had, Maddie, for your inequality? Right, so is less than strictly means less than. No more than could mean or equal to. That's her absolute top dollar she wants to spend. I would advise not moving the decimal yet, because that just makes a lot of big numbers. Let's ditch the 120 first, Brecken, by moving it as a... And let's go ahead and take care of the subtraction while the numbers aren't huge. Does that make sense? To get...
0, 1.
All right. Again, that just means while I'm doing this, because I'm going to do the subtraction anyway. If I move the decimal right off, I'm going to have to subtract really big numbers with extra zeros. Yeah, don't want to do that. Now let's go ahead and move the decimal to 2 places to make this 15x is less than or equal to 10,500. And then, of course, we have to divide by the 15. Maddie, did you do this? And what did you get when you divided away the 15? Comes evenly to 700. So she needs to drive less than or equal to 700 miles if she wants to stay under budget or on budget. Questions on number 10. Less than or equal to 700 miles. Yesterday, we began looking at absolute value inequalities, and I said that like an absolute value equation, the key to absolute value anything, class, is to have positive and negative. Class, what's the key to absolute value problems? Having positive, negative. Now, we worked for homework this problem. It was equal to 22. So we set the 4x plus 2 equal to positive and negative. And when we solved, we got equal to 5 and equal to -6. Do you remember this from the homework? But we said if it were an inequality, we wouldn't have an equal to. It would be either a greater than or a less than, or perhaps greater than or equal to or less than or equal to. But you know what's not going to change, class? The fact that 5 and negative 6 are key values. Now the graph is going to look a little bit different. With an equal sign, the 5 and the negative 6 are simply dots. If it were a greater than symbol, for one thing, they would be open circles now. But we'd also have to shade. With a greater than symbol, class, reviewing from yesterday, where do we shade the graph? There's 2 points, so to the right of which? All right, let's review from yesterday here. This is, by the way, why we give homework. I didn't give you homework over this, and hence you remember nothing. Okay, that's why homework is so important. That's okay. So remember, if it's greater than is big, right? Outside ranges. Greater than, out there, to the outside. With a less than symbol, again, because there wasn't the or equal to, we would again have open circles. Where would I shade this time for a less than symbol? In between them. So if it's small, you shade in between. Greater than, you're going to shade to the outside. Of course, just plain old equal sign like we had in the homework, it's just those 2 points. Questions on this? Of course, greater than or equal to, the only difference is you shade the dots and you shade outside. Right? You fill in the dots. But otherwise, that's really the only difference here. So that if I had a greater than symbol, the 4x plus 2 would be less than the negative 6, would be less than the, ends up being less than negative 6. I mean, your final answer is x ends up being less than negative 6, x ends up being greater than the 5. Here we would say that negative 6 is less than x, is less than 5 in the final answer. But that's essentially the only real difference is we shade inside or outside the dots. So, go and write this inequality down. Let's practice with some absolute value inequalities. Let's go and practice with some absolute value inequalities. I will say this, the key, if you write this step down, make sure you isolate the absolute value before you get your positive negatives. Gotta isolate the absolute value before you get the positive negative. Just like in solving, right? We'd isolate the absolute value, then we'd set equal to positive negative. Well, here we isolate the absolute value, then we either set inside or outside the positive negative, but the isolation has to happen first. So if we had the absolute value of 3x is less than or equal to 6, well, here the absolute value is already isolated. So class, I'm already ready to put my 3x between or outside the positive negative 6 class. Between. It is a less than. It goes inside. So what I would suggest you do is on your number line, plot your 6, plot your negative 6, and put your 3x in between it. This gives you a visual of what we're dealing with. We have these 2 dots, and the 3x is going to fall in between the dots. If you draw the picture, it will help you to remember to say that 3x falls between the 6 and negative 6. It's a visual to get you to this point. Does that make sense? Could you just say, well, I know I'm going to get positive negative 6, and I'm going to put the 3x in between. Yes, but I've found students mess up when they don't draw the picture. So my encouragement is draw the picture. And now, to solve, all I got to do is divide away the 3. Same thing we were doing yesterday. We just turned it into a compound inequality is all. What's my final answer, my final solution to the inequality, Maddie? There we go. That easy. Write this one down. Absolute value of 2x minus 1 is less than 5. The absolute value of 2x minus 1 is less than 5. Again, the first key, you've got to isolate the absolute value. Brecken, thoughts? It's isolated. So, once we know that it's isolated, now we're ready to ask, do we go inside or outside the positive negative? And we're going to go inside because it is less than. So on the quick sketch number line, again, nothing fancy, there's 5, there's negative 5. I'm going to put the 2x minus 1 in between the 5 and negative 5. So how do I write the inequality then, Brecken? Good, and now we're ready to solve. First thing we need to do to solve, Maddie, add 1 to everything. And then we have to divide the 2 away from everything, Brecken, to get? There we go. And there's my final solution. Questions on this? A quick sketch number line, just so you can get the idea of what you're doing. That'll guide you to set up the inequality correctly and to solve the inequality, like we've been doing. Write this one down. Absolute value of x plus 2 is greater than 3. Before you can do anything else, you've got to make sure the absolute value class is isolated. It is isolated. Maddie, we're ready to put our number line, and on the number line we're going to put both positive and negative 3. But what do I do with the x plus 2? I put it on the outsides because of the greater than. So Maddie, we can clearly see I've got 2 separate sets of values here. I do not have one continuous inequality. I'm going to have to write 2 different ones. My first inequality would be, is what? Good, less than negative 3. So this is a set of points that would satisfy the inequality, or the other set of points that would satisfy the inequality would be, do we see how we set up 2 separate inequalities when they're the outside ranges? But the solving is pretty straightforward. Brecken, all I've got to do is, in each case, and that's going to give me that x is less than negative 5, or greater than positive 1. And there's my answer. Or there are my answers, in a sense, if you will. Questions on this? Obviously, a point cannot be less than negative 5 and greater than 1 at the same time, right? Like if it's less than negative 5, it isn't also greater than 1. If it's greater than 1, it's not also less than negative 5. So hence the reason for the or there, if you will. Technically, it's both ranges, but the point or an individual point would have to fall into one or the other category. Write this one down. 2 times the absolute value of x plus 3 is greater than or equal to 4. 2 times the absolute value of x plus 3 is greater than or equal to 4. Should I draw my number line and put positive and negative 4, class? No, because I've not yet isolated the absolute value. Good, Brecken. What do I need to do to isolate the absolute value, Maddie? Divide away the 2, and that's going to give me what new inequality? Now it's isolated. Now I'm ready for the number line. And it's not a positive negative 4 I'm putting, class, but rather a positive negative 2. What do I do with the absolute value? Do I put it inside or outside, Brecken? Outside, because I've got a greater than. So that means I'm not going to write 1 compound inequality. I'm going to write 2 simple inequalities. What do I write down, Brecken? Well, or equal to, right? Put a little dot, that might help. There we go. So we've got x plus 3 is less than or equal to the negative 2, or x plus 3 is greater than or equal to the positive 2. And of course, in each case to solve, I simply need to subtract the 3 from both sides. That'll give me x is less than or equal, class 2, or x is greater than or equal to negative 1. And there is my 2-part answer. Questions on this? Do we feel like we're understanding absolute value? Any questions at all? All right, let me give you one more here. Make this one a little bit harder just because we can. 3 times the absolute value of 2x minus 1 plus 1 is less than or equal to 10. Should I set up a number line with a positive negative 10, Maddie? Why not? It's not isolated here. We always isolate before we do the whole positive negative thing. So, Maddie, what do I need to do? Good. Start by subtracting the 1. That is the least attached thing to the absolute value. And when we subtract away the 1, of course, we get? I'm too lazy to write the whole thing, especially when I'm going to do my next step very quickly, Brecken. Divide away the 3. And so I'm going to end up with an isolated absolute value of 2x minus 1 is less than or equal to 3. Had this been a negative, that would have affected this as well. So you can just be careful with signs through all of this. After the test, we're going to talk about what about absolute values and negatives. But we get to this point here, and now what, Maddie? Good. Now we're ready for the number line, and there's 2 key things I put on the number line. Good. Positive and negative 3. And what do I do with the 2x minus 1 bracket? I put it on the inside this time because it is a less than, which means I'm going to get all 1 range. I'm not going to get 2 separate. How do I write the all 1 range, Maddie? Ooh. How do I write this? There we go. It's going to be one continuous range. So the negative 3 is less than or equal to 2x minus 1, which is still less than the negative 3, or the positive 3. So again, one continuous inequality always uses the less thans, or in this case, less than or equal to's. From here, 2 steps still remain to solve. First, Brecken. And that'll give us and then finally, Maddie, to get and there would be our answer. Questions on this? I want you to work the practice. You're already on page 148. We did the middle section a moment ago. I want you to do the top section now, 1 through 13, the odd. Page 148, the practice, that top section, 1 through 13, the odd problems. Isolate the absolute value, then set up the number line sketch. Put your absolute value quantity either in between or outside, depending on, and then solve the resulting inequality. once you've done the first few, make sure you're on the right track. Once you've done the first few, make sure you're on the right track. Obviously, if you have questions, certainly feel free to ask. Are we good to go on the first 5? All right, finishing up those last 2 now. Once you finish 11, check your answer on that one. Make sure you're good on 11 before going on to 13. Both good to go? All right, last one. Make sure I copied it right. We've already checked 11, correct? Everyone's checked 11? I'm going to go ahead and erase 11 because I'm running out of room. Well, it certainly wasn't pretty. For sake of time, let's check our work. Did you start by adding the 6 to both sides to get a 4 over here? Did you then divide away the 3 to get 4/3? So it becomes a positive negative 4/3, right? Because of the greater than, you're going to go on the outside. So 2x plus 3 is less than the negative 4/3, or 2x plus 3 is greater than the positive 4/3. I'm like, I am not dealing with the fractions. No, I can't. So I went and multiplied everything by 3. I didn't show that step, but you see here with the 6x plus 9 is less than negative 4. 6x plus 9 is greater than 4. I'm not messing with the fraction. Subtracted the 9 from both sides to get 6x less than negative 13. Subtract the 9 to get 6x greater than negative 5. And divide away the 6. They're pretty ugly answers, but they are correct. X is less than the negative 13/6 and greater than... That's a less than symbol. Well, anyway, it's supposed to be in between. I can't copy it correctly. That's supposed to be a less than. So it was actually supposed to be negative 13/6 is less than x is less than negative 5/6. But if it was greater than like I copied, it would have been outside ranges. It was supposed to actually be that. Did y'all copy the greater than or the less than? You had the less than. So you had in between, not outside. Okay, good. You ignored the fact that I was wrong. Okay, you didn't feel like pointing out, Mr. Desk, that's supposed to be a less than symbol. None of you thought that would be good to mention. Jerks, or jerk and jerkus. All right, homework for this evening. Homework for this evening is to do page 456. We're beginning our, doing our review tomorrow. The homework will force you into reviewing some things with fractions that we began looking at in January. Page 456, number 1, 5, 13, 14, 18, and 19. So 6 problems from chapter 11 to refresh your memory on basic fractions. 1, 5, 13, 14, 18, 19. Also, there's a word problem handout that's going to be in the description of this video, Noah and Gavin, that'll help you prepare for the word problems that you will see on the quarter exam in 2 more lessons on Friday, lesson 134. Again, the exam will cover chapters 3, 4, and 11, though we taught them in the order of chapter 11, then 3, then 4. We'll take a look at the homework tomorrow. Our entire lesson tomorrow will be dedicated to reviewing for the exam. Have a wonderful rest of your day, and you are dismissed.